مساء الخير عليكم. احنا النهاردة هنكمل شغل على ال Sequential Acceptance Sampling Plan. احنا كنا خلصنا كل ال derivation في الكلاس. احنا بس فاضل عندنا 2 practicing example. احنا عندنا واحد منهم على برنولي distribution، فبنطبق تطبيق مباشر بالفورمز اللي خدناها في الليكتشر، والتاني بنغير ال distribution ل distribution تاني عشان نشوف how can we apply ال sequential sampling plan في حالة إن ال distribution is changed. how can we design it, how can we apply it and so on. فخلينا نبتدي الأول بال first example. Suppose that you have a unit sequential sampling plan for attribute with lot size 2000 وعندنا ال following parameter P1 و P2 و alpha و beta. What is required to design a sampling plan? Then you have to explain it, and then by using a walled approximation try to find the average outgoing quality with average total inspection with average sampling number approximates, knowing that in the percent of a defective item is 3.97%. Let's start first by designing the plan. If you can remember إنه the word designing the plan في sequential sampling plan بيريفير لي إنه to find ال two limits اللي هو ال acceptable limit اللي هو ال XA وال rejectable limit اللي هو ال XR. و if you can remember إن ال XA was A over K plus MS وال XR had the formula of R over K plus اللي هي ال MS. وإنه in order to be able to find ال XA وال XR we have to calculate ال A وال K وال S. ال small a كانت equal to ال len capital A، وقلنا إنه ال capital A would approximate its values by اللي هي beta over 1 minus alpha، وإنه while we calculate ال A we find it always إنها equal to negative، and we said that إنه it's a good thing to have a negative value عشان to start below ال zero عشان to prevent taking a decision في ال initial inspection stage، لأنه لو أول أو تاني أو تالت item كانوا طالعين non-defective ف most probably you will take a decision by accepting a lot after a second or third unit by at most، فده ما بيكونش favorable بالنسبة لنا. Then we calculate اللي هي ال small r، وال small r هي len capital R، و would approximated the value of the capital R with 1 minus beta over alpha، وإنها it's always a positive value. Then we have to calculate ال K according to our derivation in ال K is function في ال P1 or P2 ف by substituting with the values of P1 and P2 we get in ال K is equal to 2.3979, and then we should calculate ال S after calculating ال K since in ال S but depend on the K فال S is equal to len 1 minus P1 over 1 minus P2 divided by ال K and we get its value as 0.0397. Then we substitute with all these values in ال XA and ال XR ف we reach ال final form بتاعتهم. Remember that in ال XA وال XR are not constant like the other sampling plans we have taken، لأنه ال XA وال XR depend on ال M وال M بتريفير لي ال number of ال items inspected، ف this means that for each item I have to calculate ال XA and ال XR. This is a designation of the اللي هي ال plan. The second requirement was to explain the plan. طب how can we explain it? We explain it by saying that إنه we take single units sequentially from the lot, and after taking each item we inspect it and then we identify whether or not it is defective. And based on this classification, we calculate the cumulative number of defective items, which we refer to as a DM, and we calculate the XA, acceptable limit, and we calculate the XR, rejectable limit. Suppose that we are inspecting the third item, then in this case, the M is equal to 3, then I have to substitute in XA with M equal to 3 and in XR with M equal to 3. Then we start to compare a DM with both limits, the XA will XR. If it happens that in the DM is between the two limits, XA or XR, then our decision should be continue sampling. Then we go to the lot and take another unit, we inspect it, and we repeat the whole process all over again. Or if it happens that you find in the DM is less than or equal to an acceptable limit, XA, then your decision should be accept the lot and stop. Or if it happens that in the DM is greater than or equal to an XR, a rejectable limit, then your decision should be reject the lot and stop. This is the explanation of the plan. Third, according to the third requirement, we need to use a walled approximation in finding the average outgoing quality with ATI with ASN approximates, assuming that in the percent of defective item is 3.97%. Recall that when walled provided the approximation for these measurements or performance measurements, he provided for each one two formulas based on whether or not the expectation of the ZI is equal to 0 or not. According to our derivation, we find out that in case of the Bernoulli distribution, in the expectation of the ZI is equal to 0 if NLP is equal to S. And it will not be equal to 0 if NLP is not equal to LS. In this case, first we have to check the condition whether or not P is equal to S so that we can identify which formula we are going to use. Here, according to our calculations, the S was found to be 0.0397, and according to the given, the percent of defective item is 3.97%, so dividing by 100 we get 0.0397. So this means that P is equal to LS. Accordingly, all the approximation should be the formulas corresponding to the condition that NLP is equal to LS. Here we need to calculate the AOQ, ATI, ASN. All of them depend on the probability of acceptance in their calculations. So this means that I have to calculate the probability of acceptance first, and then I should go to the calculation of the AOQ, ATI, ASN. P hat A, or approximation of the probability of acceptance, a formula corresponding to the situation in P is equal to S is R over R minus A. Plug in the values of R and A, we get 0.5621. AOQ approximately is equal to P multiplied by PA, and the PA we have just calculated it, so we substitute and multiply by a percent of defective item in a lot given in the question. So we get in the AOQ is equal to 0.02231. Recall that in AOQ is always less than LP. So one of the validation of your calculation is to get an average value for outgoing quality less than a percent of a defective item. Then we have to calculate the ASN, and this formula of the ASN which depend on the expectation of ZI square and the ZM square. This is the formula. Substituting by probability of acceptance we have just calculated, we get approximately 30 units. This means that on average we would sample 30 units from these lots. Take into consideration that in the calculation of the ASN will provide you a number with fraction or decimals, so we usually approximate above or to a higher value. We approximate to the higher value. Then we have to calculate the average total inspection, and if you can remember, the average total inspection take part from the average sampling number. So by the calculation, we find out that on average we shall inspect about 889 units. This is the first example. Let's go for the second example. In the second example, it is required to find the form of the SPRT for testing H node lambda equal to lambda 1 versus H1 and lambda equal to lambda 2, assuming the Poisson distribution. What would be the Poisson distribution in this case? Let's recall the case and we worked on the Bernoulli distribution. The case was إن إحنا كان بيجيلنا lots. We inspect each item and we classify each item into either 0 or 1, defective or non-defective. For this inspection can be generated XI اللي هي random variable, واللي best model this situation كان Bernoulli distribution. هنا I'm requiring إن ال xi to follow ال Poisson distribution. طب how would that be in case إن أنت بتعمل classification ل defective و non-defective؟ هنا الكيس إنه إحنا مش بنجيب اليونت وبنعمل لها inspection ل defective و non-defective. Remember إن ال definition generally بتاع ال Poisson distribution هو عبارة عن distribution refer to a number of events that occur within interval أو within an interval. في الابليكيشن بتاع الكواليتي كنترول بيبقى حاجة something like مثلا إنك أنت بتimport من بره قماش. الانفستيجيشن بتاعك بيكون by taking pieces من اللوتس دي وبتكاونت النمبر of the defect per piece. فاكتولي ال XI هنا هي النمبر of the defect اللي you find it in the piece of cloth. Taking into consideration the piece of cloth دي هي اللي بتrepresent ال interval وال number of defects هي ال number of the events. فال best distribution to model this is the Poisson distribution. This is one of the application well known في ال quality control. هنا احنا بنيجي نقول اننا I'm having two lambdas بقى lambda 1 و lambda 2. اللامدا بتrepresent the average of the Poisson distribution. So actually lambda 1 representing the acceptable process average, meaning that in the lambda 1 بتrepresent the acceptable average of defects per item. واللامدا 2 is the rejectable process average ده represent the average number of defects per item that is considered to be rejectable. وسنس انه اللامدا 1 واللامدا 2 represent average of defects فبيولوجيك اللامدا 1 هتكون less than اللامدا 2 باعتبار ان اللامدا 1 هي ال acceptable level واللامدا 2 ده ال rejectable level من ال number of defects per item. We here require to design a sampling plan, then we require to use a word approximation in finding a probability of acceptance with ATI with ASN, and then we assume some values for the parameters, and accordingly we need to calculate a probability of acceptance with ATI with ASN at lambda equal 1.5, and we will explain later what's meant by in the lambda is equal to 1.5. If you know that in the non-zero value of t in case you need it is equal to this, and this results from the solution of a moment generating function by equalizing it by 1. Let's start by designing the plan. Recall again in designing a sequential sampling plan, meaning that you have to find the XA with XR, the acceptance limit with rejectable limit. Here we cannot directly use the formulas we got in the Bernoulli. We have to start from scratch, extracting or derivating the XA with XR. طيب, recall that in order to design it, we say that after the inspection of each item, we have to test each node in the lambda equal to lambda 1, meaning good quality, versus H1 and the lambda equal to lambda 2, which refers to bad quality. And this is equivalent to the SPRT, and accordingly the test statistic would be the likelihood ratio F of a joint X's given lambda 2 bad quality divided by a joint PDF of the X's given lambda 1. When in this situation X would follow a Poisson distribution, so F of X will be having the form e to the power minus lambda, lambda to the power X over X factorial. Now what we need is to take this PDF formula and substitute in the numerator and the denominator of the likelihood function. Here we substituted in the numerator with the PDF of the Poisson while substituting lambda with lambda 2, and then in the denominator we substituted with the PDF of a Poisson while substituting a lambda with lambda 1. And we have the multiplication sign outside. You can see here that we can cancel a factorial xi in the numerator along with this with the one in the denominator, and then we can enter a multiplication formula inside دي اللي هو البراكت. So here we have in e to the power lambda 2, this is a constant, so the multiplication would change it into e to the power negative m lambda 2, and then the multiplication would change the power of a lambda 2 into summation xi. The same would happen in the denominator. The only change is that we are working on lambda 1 instead of lambda 2. دلوقتي بقى نقدر نلم الحاجات اللي شبه بعض مع بعضها. So we have here in e to the power negative m lambda 2 minus lambda 1, and then we have lambda 2 over lambda 1 with a common factor اللي هو الpower summation xi. For simplicity, we don't work with the likelihood ratio, we work with the log of a likelihood ratio, so we take a len for simplicity. So here E is cancelled and this is the remaining part, and then هنا summation xi from الباور هنا بتنزل تحت جنب اللي هي len. recall بقى ان sum of xi هنا كانت بتrepresent ال dm. Based on the definition of a dm هو represent the cumulative number of the defective item till the investigated item رقم m. هنا it is the same, I preserve the same definition of ال DM. هو بس الفكرة ان احنا we can say that انه السم xi هو represent ال cumulative number of ال defects per item. مش بقى cumulative number of defective، لا هو cumulative number of ال defects per item till item number m. يعني for example if I investigated the first piece of cloth and I find out that إن I am having 4 defects، وال second piece of اللي هي الcloth I found out 2 defects، يبقى in this case the DM would be 4 plus اللي هي 2 that's equal to 6. By the way عشان برضو تبقوا فاهمينها، هو ازاي انا ممكن الاقي defect؟ بمعنى لو انت عندك piece من القماش وبتعمل لها investigation، ممكن مثلا تلاقي خرم صغير فيها، ممكن تلاقي قطع فيها، ممكن تلاقي ان مثلا ليها رسمة معينة في حتة معينة الرسمة مش ماشية مظبوط مع بقية الرسمة في الحتة دي، يبقى كل دي عبارة عن defects. انت بتعد كام defect per البيس ده او per الايتم ده، ويبقى هو ده ال XI بتاعت this item. طيب here we said that انه if you can remember انه لو حصل ان ال likelihood كانت having a very high value، ده معناها ان انا بتند هنا بقول ان distribution is more likely coming from lambda 2 اللي هي bad quality، وان انا I should tend to reject. ولو حصل ان هي was having a very low value، ف this means that most probably انا جاية من distribution عند lambda 1، ف in this case ان انا I should tend to accept اللي هي lot. وانه لو ده ما حصلش وده ما حصلش، فإن المفروض في الحالة دي I continue sampling until I would be able to take a decision. In this case I take اللي هي len of the likelihood ratio and I put it between the two values A and R. Then I take this quantity by addition on the right side and on the left side. وبما إن هو addition and subtraction that does not affect the inequality direction. Here we have, if you can see that in the main decision is based on the comparison of a DM with the limits اللي هم ال XA and اللي هم ال XR. فهنا we have to بقى divide both sides by len lambda 2 over lambda 1. Before dividing this quantity you have to investigate it first whether it is a positive value ولا هي negative value. Based على logic أو definition we have إن lambda 2 is greater than lambda 1. So this means that in the lambda 2 over lambda 1 is a value greater than 1. But in this case, the len for this would be a positive value. But this means that if I'm going to divide by it, the inequality direction would be preserved. So I divide by len lambda 2 over lambda 1. I get this formula. وأنا I know that ال XA اللي هو acceptable limit بيتake the form of A divided by K plus MS. And the rejectable limit اللي هو XR بيتake the formula R over K plus MS. In this situation I can say that in this I can name it K, all this I can name it as S. And you can see that in S would be lambda 2 minus lambda 1 divided by K. يبقى here we define ال K as len lambda 2 over lambda 1 and ال S as lambda 2 minus lambda 1 over K. As you can see that إنه the same steps we followed in Bernoulli we follow exactly the same in the Poisson distribution. ال XA formula وال XR formula في الجنرال فورم بتاعتهم it does not change. ال only change جاي في شكل ال K وفي شكل ال S. Okay. The second requirement was to use a word approximation for a probability of acceptance وال ATI وال ASN. وهنا I didn't require ال AOQ لأنه after all ال AOQ is not an approximation from Wold. هو approximated formula generally في ال AOQ و Wold since إن هو بيuse approximation فهو he used the approximation formula for ال AOQ. طيب in order to be able to identify a word approximation or to identify it we have to know when the expectation of zi is equal to 0 when the expectation of zi is not equal to 0 لأنه the formulas provided by Wold depend on these two conditions. طيب ال zi if you can recall is equal to ال xik minus ال ks. So if I would have an expectation of this quantity I would be having expectation of xi where rest is considered to be constant. The expectation of xi in the Poisson distribution is equal to a lambda. Even in this case by taking ال k as a common factor I would be having a lambda minus ال s. طيب هنا بقى when shall the expectation zi equal to 0 it would happen if a lambda is equal to ال s. If a lambda is not equal to s the expectation بتاع zi is not going to be equal to ال 0. يبقى these are the conditions. طيب الجنرال approximation بتاع probability of acceptance provided by اللي هو الوولد depend on this. يبقى I can deduce that إنه the probability of acceptance would be given by this formula if a lambda is not equal to s. This is the case إنه the expectation of zi is not equal to 0 or it would be equal to r over r minus a if a lambda is equal to s. Okay. ال AOQ طبعا هي P of PA. And then as for بقى ال ASN اللي هو ال average sampling number if you can remember إنه Wold approximated ال ASN as expectation of ZM divided by expectation of ZI. بس if it happens that an expectation ZI is equal to 0 فبتبقى expectation of Z square M over expectation of Z square I. وإنه in this case بقى accordingly we have to find the expectation of Zi with expectation of Zi square. طبعا expectation of Zi this is the one we have just obtained اللي هي lambda k minus sk. The expectation of Zi square I should return back to Zi. I have to square it and square this quantity and then I shall put the expectation. You will find out that in one of the expectation required is expectation of xi square which is equal to the variance plus the expectation square. Well, variance of the Poisson is equal to a lambda. It would be lambda plus lambda square. By working out this, you will find out that it ends to be an expectation z square I is equal to k square multiplied by ls. As for Zm, the definition of Zm will not change because of the change of the distribution. It will remain the same as in Wold approximated the value بتاعت Zm to be equal to A in case of the acceptance and R in case of the rejection. And if it happens that you are going to work with Z square M, then you have to square it. It is approximated by A square in case of the acceptance and R square in case of the rejection. Dealing with it as a discrete random variable, then we have an expectation Zm, A for probability of acceptance plus R for probability of rejection. And the expectation of Z square M would be A square probability of acceptance plus R square 1 minus PA اللي هي probability of rejection. Now we can find بقى الفورمولا of ال ASN that would be ال A over K lambda minus S في ال PA plus ال R over K lambda minus S1 minus PA that in case the lambda is not equal to ال S. Here if in the lambda is equal to S then the main change would be in this would be A square وهنا it would be K square S and the same is here. Then I can approximate the ATI by using this part of the ASN. If you can remember, I can say that the average number of the items to be inspected would be, in the case of the acceptance, اللي هو the average number of sampled item, or in case of the rejection, I would inspect the whole item. the whole lot. And here, if in the lambda is equal to ls, then this is expected to be the average number of items to be sampled, and accordingly it would be the average number of an inspected item, plus it would be the whole lot if I would reject. These are the formulas for the three measurements, cell P of A والATI والASN. The third requirement is to assume in we have beta, alpha, lambda 1, lambda 2, and lot of size 2000. We need to calculate a probability of acceptance والASN and the ATI at lambda equal to 1.5. What's meant by a lambda equal to 1.5؟ هنا this is the process average أو this is the اللي هو lot average. زي بالظبط ما كنا بنقول in the case of the Bernoulli إن أنا I am receiving lots with P equal to something. This means that إن اللوت دي فيها average percent of defective item equal to something. هنا اللامدا is equal to 1.5 معناها إن أنا I am receiving lots by which إن on average it has 1.5 defect per item. يعني زي بالظبط الكلاس اللي احنا بنعمله importing إنه بقول إن on average in each piece of class have 1.5 defect on average. Okay, so it's equivalent to P, the percent of defective item. And here this is the non-zero solution for LT if needed. Type. First of all, I have to calculate LS so that I would be able to identify which formula I am going to use from the Wold's approximations. والS depend on the K, so I have to calculate the K first. So calculating the K as then lambda 2 over lambda 1, then calculating the S based on the K, I get 2.48. Here S is equal to 2.4 while in the lambda is equal to 1.5. This means that in the lambda is not equal to S. Even in this situation, I'm working under the formulas corresponding to the case in the expectation of Zi is not equal to L0. يبقى here we have to calculate بقى ال probability of acceptance والASN والATI بس we would be needing اللي هو ال values of ال A small وال R small, so I shall calculate them when the definition will not change because of the change of the distribution. It would be the same, beta over 1 minus alpha or 1 minus beta over alpha. Then we shall calculate the probability of acceptance, and this probability of acceptance will be depending on the one having a T in its formula علشان and then I am having an expectation is not equal to 0 with T is given for U. Then I have to calculate the ASN using the formula corresponding to the case and the expectation is not equal to 0. وهنا I'm using the probability of acceptance, the one I have calculated above, and I would be having 1.6, which we can say approximately 2 units. يعني on average you are going to sample 2 units. The average total inspection would be this formula and it would end up approximately 119, which means that in approximately I shall inspect about 119 units on average.